everyone, this is Doc Brown's Radio Lab. I'm coming at you with something a little bit different today. We have a little bit of a automotive / lawn tractor engine starter troubleshooting video to give you today. Now I am in my garage, and to start things out I'm just going to let you know that first of all, as a little disclaimer here, this is not a tutorial. Don't do anything you see in this video as proper procedure, and I am only showing you my experiences with what I had to do today in order to troubleshoot this lawn tractor. Now, there's only one camera operator here, and that is me, so I'm going to have to come over here to show you what's going on. So, this is a snapper lawn tractor. It's a 23 horsepower Briggs and Stratton V-twin, and we had a failed starter today. It's actually kind of funny what happened, because I was out doing some yard maintenance and my father was on this tractor, and he came over and shut the engine off to talk to me for a couple minutes about something, and I asked him how's his tractor running when the engine was off, because you know we had a couple issues with the drive belt for the deck was a little loose and a couple other minor issues. So I was just asking him how it was working, because I just greased the axle fittings, grease fittings for him and whatnot. And I said, how's the tractor running? And he said, it's running good. And then he went to go start it, and uh-oh, it wouldn't start. Imagine that. So we had a little bit of an issue. So me being the electrical guy in this house, what I did was I got out my multimeter, which you can see there, and I started diagnosing the issue. So what I'm going to try to explain in this video is some of the steps that I took in order to diagnose the issue with a no crank, no start situation on this tractor. So, because for whatever reason I cannot zoom in while I am recording on this camera, I am going to pause the video and I'm going to get the camera in a different position down here so we can take a look at the electrical section, and I'm kind of going to walk you through some of the procedure that I took in order to come to the conclusion that we had a bad starter. So, please bear with me. Through the magic of video editing, you will only have to wait 1 second. I will be right back. Alright, I'm back again, and I really hope you're going to be able to see this. I zoomed in down to the electrical section down here in this tractor. Now, I already removed the starter and diagnosed it, so I'm just trying to go back and show some of my steps of what I did. So I removed the battery. So the battery sat right here. Here's our positive terminal, and then here's our negative terminal, which is chassis ground. So what I did, the first thing of course that I did was I took my meter and I checked across the battery. And I read 12.8 volts, so I knew the battery was good and the problem simply wasn't a dead battery. So then what I did was I went over to the starter solenoid. Now this right here is a starter solenoid. Think of it like a big relay or a contactor. That's all it is. There's two, hopefully you can see them, there's two little spade terminals right here. There's a black wire and there's a white wire. Now that is your low voltage, I shouldn't say low voltage because it's the same voltage, but it's your low current side of the starter solenoid. So the way this tractor works is there are a series of safety switches or dead man switches within this tractor, so that if certain conditions aren't met, the engine will not start. Power will not be delivered to the starter motor. So for example, there's a switch for the seat, so there has to be enough weight on the seat in order to close the switch. There's another safety switch on the brake. You have to have your foot pushing the brake all the way down in order for that safety switch to close. And there's a couple other miscellaneous safety switches, such as the one for the PTO switch that energizes the deck, the electric clutch that drives the deck. If the deck is on, the engine will not start. So it's like a dead man switch, so that if you're mowing the grass and you fall off the tractor, the engine shuts down, because the seat switch will open and cut power to the engine ignition system. So what I did was I had my father sit on the tractor and act like he was going to go start it. He had weight on the seat, he had his foot on the brake, the PTO was disconnected, and he turned the key. So what I did was I took my multimeter and I measured the control voltage, I'm going to call it control voltage, coming into the starter solenoid. And I got 12.8 volts there. So that was good. That told me that all the safety switches were closed. Now the way I understand it, I did not look at a wiring diagram, but the way it makes sense to me was that all the safety switches, they're all wired in series. So all the safety switches have to be closed in order for the starter motor to receive power. It's like a proofing system. So the fact that I had 12 volts at the starter solenoid with the key on and the ignition, everything like you were starting it, that told me that all the safety switches had continuity and we were successfully delivering power to the starter solenoid. Because if any number of those safety switches were to be open, the series circuit would be broken, there would be a break in the chain, so to speak, and we would not get power to the control side of the starter solenoid. So I knew that all the proofing circuits before the starting solenoid were good. All your switches and everything, they were all closed. So the next thing I did was I had him energize like normal to start the engine, and I put one lead of my multimeter onto the ground terminal, the negative terminal of the battery, and I took the positive terminal and I probed right on the starter motor positive terminal, and I was going to see if we were getting voltage to the starter motor. And I was getting about 1.5 volts, so there was a big voltage drop. Now what I did then was I went to the starter solenoid. So I want to mention that I first suspected the problem lied within the starter solenoid. Now the reason I am making this video is to show that the problem in fact was not the starter solenoid, and it was the starter motor itself. But I was first suspect of the starter solenoid due to the fact that it was chattering, like a chattering contactor. It was pulling in and out, in and out, in and out, but it wasn't actually sending power to the starter motor because the starter motor was not turning. Well, it was. It was sending power. I'll give it that. I'll explain in a minute. So what I did was I took my multimeter and I put my leads across the two starter solenoid terminals. So you have one right here that comes right off the positive of the battery. It goes to one side of the starter solenoid. The other side of the starter solenoid is right here, and it goes down to the starter motor. It's been disconnected, but it goes right to the starter motor. So I took my meter in DC volts and I measured across the starter solenoid, and I measured 12.8 volts without the ignition being on. And that was good. That told me that there was an open circuit because the starter solenoid was not pulled in because the ignition wasn't on. So there's going to be potential across those two sides of the solenoid because it's open. So that was good. That tells me I'm getting power to the solenoid. The next thing I did was I had my father try to start the tractor, and I observed that voltage reading went down to 0. Now that is good because that showed me that the starter solenoid was closing, like it should. Then in theory, I should have power to the starter motor. But the problem was I was not reading 12 volts to the starter motor. Well, it turns out the starter solenoid was good, but the problem lied within the starter. Now if you notice something about the starter, here it is. Look at the positive terminal. It broke off. So this positive terminal, this is where the battery cable was that went to deliver power to the starter. The other side of the starter is just case ground. So what had happened was there was an internal fault with the positive terminal where it broke off the whole piece. I actually have it in my pocket here. Let me get it out. Whoop, I actually don't have it in my pocket. I must have misplaced it. But anyway, I left it inside. But the whole terminal was all blackened and broken, and it actually broke. It came right out of the housing here. And there's a commutator down there, and there was no brush left, so it all just burnt up and wore out. Those brushes wore out. And what happened was, this terminal was, I believe, what was going on was it was actually shorting out to the case, because it was not making contact in there, the starter wasn't running, and it was draining the battery down. So the next thing I did, because I started to suspect the starter at that point, was I took my meter and I measured across the battery. Well, my father went to start the tractor, and I noticed it was drawing the battery voltage down way farther than it should be. It was down to about 1.5 volts, something like that. So I said, whoa, something shorted here. So that starter had internally shorted at that terminal, and it broke loose. So what I did after that was I went to remove the starter to disconnect it. And when I went down to the terminal, here's what really got me. When I went down to this terminal to disconnect the wire from the, here it is, from the terminal, this was all loose. And it actually broke off in my hand. Just touching it, it broke off. And I'm like, there's your problem. So this was real difficult to get this out because the end of the bolt that goes through, that whole piece was broken. So the nut, when I went to loosen that terminal, it was turning the whole thing and it snapped off. That's why it's missing here. So that's what I did to actually diagnose the problem lied in the starter and not the starter solenoid. And the other thing that I did, like I already mentioned, was I disconnected the control voltage and I tested everything there to make sure that was all good. So I learned that everything over here was okay and the problem was the starter. I hope that makes sense. I tried to explain some of my electrical troubleshooting because I kind of did a lot of it at once. And I didn't feel like filming the actual troubleshooting process because we were out in the yard. So, I hope that makes sense. If anyone has any comments or questions, please leave them in the comments. And I'm going to go ahead and pause this section of the video. And we're going to next talk about what I had to do to actually remove the starter from the engine because it was a little bit tricky. So please bear with me and I will be with you in one moment. Alright everyone, I'm back and I have zoomed the camera down into position on the engine block where the starter mounts. I'm going to get down here and show you. Here's your starter and it mounts right here. Right here. You can see the space here in this shielding piece. So that's how it mounts. And you can see the Bendix drive. Obviously when the starter engages, the Bendix drive lifts up and it engages with the flywheel to start the engine. Now this starter was a little bit tricky to get out. First what I had to do was I had to remove the cowling, the engine cowling, the plastic covering around the whole engine, and the flywheel guard. I removed both of those and I removed the air cleaner. And then what I had to do, by the way, to get the cowling off, I just took off the bolts that are around the perimeter. That came right off. And then the next thing I did was I disconnected this spark plug wire and I unbolted this shielding. You can see there's a bolt, I don't know if it's probably off frame, but I unbolted the shielding, which I'm going to go ahead and do again just to show you here what that was like. So I took out the bolt that holds the shielding in place, and the shielding just pulled away. So just like this, it just pulled down out of the way to give us better access to the starter. Now the tricky part about the starter was there's two bolts that mount the starter to the engine block. One of them is right here, and it was real easy to get to. Just comes right here. This model does not have the little piece that guards wires. I know some of these engines there's a wire guard that goes along with that bolt because there's wires that run next to the starter. This model does not have that, but the tricky part was this other bolt right here. Now one thing I want to show you that some people don't know on this Bendix drive, if you look at this bottom piece of this Bendix drive, you'll notice there's a flat spot. There's a flat spot here and there's a flat spot here. Now what that flat spot is for is that is to give you better clearance to be able to get your tool in to take out these bolts. Because the way this is aligned down here, when this starter is in position, this right side bolt is really difficult to get out, especially with this shielding here. The shielding, this piece of the shielding right here prevents you from getting your socket in there. So what I did was I rotated the Bendix until we see the flat spot, so we were able to get some clearance down into that bolt. I undid this piece of shielding and I was able to get an extension down in there, and we were able to bite on that other bolt to get it out. But it was a little bit tricky. So if you don't know that, if you're ever changing a starter on one of these, there's one bolt right here that holds the shielding on. Pull the shielding back, and there's another bolt underneath that to remove the shielding entirely. It'll definitely be a big help if you remove this piece of shielding. Can you even see that? I'm sorry. Let me show you the shield piece. Right here. This shielding, there's one bolt right there, and this whole thing pulls out of the way, and there's another bolt if you want to remove it. So that'll make your life a lot easier if you remove that shielding. It'll give you better access to get in there. And all you do is you turn your Bendix to the flat spot, and you can get your extension right in there to undo the other bolt, and then the starter simply comes right out. And then what I did was I cross-referenced the number that's on the starter. There's a part number right there. Where is it? Right there. Can you see it? Probably not, but there's a part number right there. And I was able to get the correct starter for this tractor, and we have ordered it. And I'll probably make another follow-up video to this when the new starter arrives, and we will show you how to replace and reinstall the starter and reinstall the engine cowling and get everything all put back together again. But that is a good technique to, if you're changing one of these starters, to make sure you know about the flat spot on the Bendix and make sure you're able to remove that shielding there to give you better access to it. Because it can be tricky. If you, at first I thought this whole thing might have to come out because it was really blocking it, but even with the flat spot on there, but that shielding, pulling the shielding away really helped me get access to that much better. So that is how we diagnosed a bad starter on this tractor. And I like to make these videos once in a while because I know, especially in the automotive world, the HVAC refrigeration world, a lot of trades a lot of majority of problems are electrical. And I know a lot of people struggle with electrical issues. Some of them can be complicated, especially if you're dealing with big wiring harnesses like you have in these applications. You got big wiring harness, a lot of things going to different places. You got relays, you got switch contacts, and some of it can be difficult. And I like to explain these things and try to help you out with good ways to diagnose stuff so that you're able to figure out if it is your starter solenoid or if it's your starter motor, stuff like that, because sometimes it's kind of hard to tell. At first I thought it was a solenoid, but then I narrowed it down to being the starter. But I think, did I mention that I jumped those two out? I think I did. The way I was able to tell was I jumped out that solenoid. The two wires just jumped right out of the starter, and the starter didn't run. If the starter ran, I knew the problem would have been in the solenoid. And then, of course, before you can condemn the solenoid, you have to make sure you are getting control voltage to the solenoid. Because remember, if there's any other wiring problem on the front end before the solenoid, that solenoid's not going to pull in if you don't have 12 volts. I keep saying 24 volts because that's a standard control voltage in a lot of applications. But this is 12 volts, same as the battery. It's just your low current side. So I hope that helped you out a little bit. I just kind of wanted to just make a video for fun and give a little bit of insight on the project I had to tackle today and what I had to do to come to the conclusion of a bad starter motor. The other thing I would like to let you know is please keep in mind in the following week or so I'm going to do an autopsy on this starter, and we're going to find out exactly what failed inside this starter motor and see if there's any internal damage to it. So that might be interesting, so stay tuned for that. So, let me see if I can get myself in frame here. I hope I'm in frame. I can't really check, but anyway, thank you guys very much for watching this quick episode of Doc Brown's Radio Lab. I hope you learned something, and stay tuned for more videos in the future. Like I said, we're going to do an autopsy on that starter, and we will hopefully be doing another video showing the replacement of the starter when we get the new starter in. So, that is just a little bit of automotive diagnosis with Doc Brown's Radio Lab. Thank you very much for watching. And just to show you here, the meter that I was using was my OON B35T. It's a Bluetooth multimeter. I would highly recommend this meter if you need something that's going to be good. It's an inexpensive meter. Obviously, guys, don't use this on high energy stuff. It's good for mains voltage. That's about as far as I'm going to take it. But it's great for electronics. It's got a lot of features on it. It's got capacitance, it's got temperature, it's got amps, it's got Bluetooth data logging. So this is great for automotive. If you're in the market for an inexpensive automotive meter, while knowing that it's not a fluke, and by the way, I'm not sponsored by OON either. This is just the meter that I bought, and I like it, so I'm just recommending it to you. If you need a good automotive automotive meter, but you know you're not getting a fluke here, just need a good handy meter for electronics troubleshooting, I would recommend this one. They have a newer model. I forget what the newer model was, but this is a B35T, and the Bluetooth function really comes in handy. If you're working on, let's say you're working on an O2 sensor or an oxygen sensor in a car, and you can't be out there probing it, you could just have the Bluetooth go right to your phone, and it'll tell you your readings. Really handy stuff. So, thank you guys very much for watching, and I'll see you next time. Take care.